Hey everybody, Mr. Morrell here, and we're gonna keep looking and talking and thinking about these weird, cool, curvy, exponential functions. So in this homework assignment, we're talking about growth and decay. So here's the deal: exponential functions are crazy in terms of how much they're used in real life. Like, this is exactly what banks and credit cards and loans and science and all those things, like, that's kind of this, they use exponential functions a ton. And so what we're going to be doing today is talking about exponential growth and decay, and we're going to try to put it into some contextual values so that you could see how to write up one of these functions and maybe use it in the future. So the first thing that we have to do is we have to talk about converting between a percentage and a decimal, because while percentages are super nice and easy to talk about and to use when discussing money or growth or whatever, we can't really type a percentage sign into equations and or calculators or anything like that, so we have to be able to convert back and forth between the two. So the way that you would make those changes is that I have this box right up here at the top to help you out. So to change a percentage to a decimal, you just need to divide that percentage number by 100. And if you want to change the decimal into a percentage, you would multiply by 100. So we're just going to go ahead and do that. Right here, you're probably just going to want a calculator out. I've got mine out and ready to go, and I'm hoping you start to see some patterns as we do that. Okay, so 25%, we want to convert that to a decimal. So in my calculator, I'm typing 25 divided by 100, push enter, and I'm getting 0.25. I'm dyslexic, stop making fun of me. 0.25, and the calculator's saying 0.25, and you don't have to write that 0 before the decimal, but you can. Okay, so number 2, I want to convert that decimal to a percentage. So 0.97 times 100, enter, is 97%. Okay? Percentage 89%, so 89 divided by 100 is 0.89. Now you want to be careful with number 4, 0.5, especially if you're starting to see a pattern. 0.5 turned into a percentage. Most people would kind of naturally write, hey, that's 5% because it's 0.5. But no, if you're using your calculator and being careful, that's 50%. You have to move the decimal to the right 2 places if you figured out the trick already. The percentage, 3% isn't 0.3. Don't write 0.3. It's 0.03. And the decimal 0.05, that is 5%. So you just want to be careful if you're using any sort of tricks or anything like that. Make sure that you're careful in using your calculator if you need it. Alright, so let's look down here. An exponential function is always going to look like this. You recognize this from the geometric sequences. The only thing that's changing here is that we're changing the words, the things that we're calling things here. Like before, we were calling it the 0th term and the constant ratio, and that's true for sequences, but now that we're talking about more than just sequences, we've got to start calling it other stuff. So the trick with this assignment is going to be finding the multiplier, but look, I've got little helpers right here. We're going to find the multiplier. First of all, you're going to want to decide if it's a growth or decay multiplier that you're looking for, because that's going to tell you what instructions you should do. And you're just going to follow those instructions exactly the way that they're said. So let's go ahead and I want to do all of the questions on the left with you. So question 7. A function has an initial value of 5 and a 12% growth rate. So what we know there is that the initial value is 5 and it's growing at a rate of 12%. So I'm going to come up here and I want to use the growth instructions. So the first thing I need to do is convert the percentage to a decimal. So I'm going to do 12 converted into a decimal. 12% is going to be 0.12, And then I want to add a 1 to that. So our multiplier is going to be 1.12. So our function here is going to be 5 times 1.12 to the x power. Alright, number 9. A function has an initial value of 0.23 and has a 31% decay rate. So what we're going to do here is we will have an initial value of 0.23. And our multiplier, well, let me follow the decay instructions up here. We're going to do 100 minus the percentage of decay. So 100 minus 31, I'm doing that in my head, I think that is 69. And then we're going to turn that into a decimal, which would be 0.69. Okay, now the next one. We have to kind of figure this one out. We know we're going to have blank times blank to the x power. A piece of bread began with 5 mold spores. So that's our initial value right there, is 5 mold spores. And the amount of mold is growing at a rate of 9%. So I'm going to follow the growth instructions, convert the percentage to a decimal, 0.09, and then add 1 to it. So 1.09 is going to be our percentage growth there, or our growth multiplier. Alright, let's go on to the back side. This time I'm giving you a function, and your job is to figure out what percentage of growth or decay there is. And it's kind of like we have to think backwards through everything. So the first thing that we're going to have to do is find our multiplier, and then we check to see if it's bigger than 1 or if it's between 0 and 1. And then from there we're going to follow instructions, because that's going to tell us if we're growing or decaying. So let's look here. Our growth multiplier is 1.25. And so first of all, we want to ask ourselves, is that growing or decaying? Well, 1.25 is greater than 1, so I know that it's growing. And so what we're going to do here is follow these instructions. I'm going to convert the multiplier into a percentage. So 1.25 is going to be 125 in terms of a percent. Then I'm going to take that percent and subtract 100 from it. So 125 minus 100 gives us 25% growth. Alright, now let's come down here to question 18. Here's our growth multiplier. It is 0.89. I know that number is smaller than 1, so we're looking at a decay. So I need to convert that multiplier into a percentage, so that would be 89%. And it's tempting to write that this is 89% decay, but it's not. Look at our second step here. We know we need to do 100 minus 89%, which would be an 11% decay. Excuse me. So, I know this is kind of confusing, but I typed up this box up here at the top to help you think through those questions. And then down here we just have some real world situations, and these are real world situations. So take your time, go ahead, and you're you're just going to try to answer the questions. I think in every single one of these questions you're probably going to want to write a function, and then from the function that you write you're going to want to answer the question. So that's my recommendation. I will talk to you guys later.